A sample of uraninite, that is a uranium containing mineral, was found on analysis to contain 0.214 grams of lead for every gram of uranium. It means your uranium has been disintegrated and there are 0.214 gram lead for every gram uranium. Right? Now, assuming that lead has resulted from radioactive disintegration of uranium, since the geological formation of uraninite and all isotopes of uranium other than U-238 can be neglected. It is saying that in the uraninite ore, the uranium has resulted from radioactive disintegration of lead. Lead has resulted from radioactive disintegration of uranium. Right? You have to estimate the data when the mineral was formed in the Earth's crust. The half-life of U-238 is 4.5 into 10 to the power 9 years. It should be 9 over here. Right? Now how will you find out? What I told you was we have got this many grams of lead. Right? Now this means that final concentration, we know that this many grams of lead are there. Can we find out the amount of uranium? We can find out, right? No, I think I have to just take up one more whiteboard. Let's take up. Say the lead 206 is how many grams? It is 0.214 grams. Let's find out the number of moles of lead. What it would be, how much it would be? It would be 0.214 by 206. So how many moles of lead are present today in that rock? So it would be 0.214 divided by 206, and that would be equal to 1.039 into 10 to the power minus 3 moles, right? So this many moles of lead are present today. And how many moles of uranium would be present then? So the number of moles of U-238 today. So what was it saying? That it is 0.214 gram per gram of uranium. So it would be 1 divided by 238, and this will give what? So it is 1 divided by 238. It would be 4.2 into 10 to the power minus 3 moles. Right? Now, this lead 206 has been obtained from what? From U-238 only. So what will be the initial concentration of U-238? The initial number of moles, because we can't go to that time period and find out the number of moles, initial number of moles. So the initial number of moles of U-238 will be equal to how much? The lead, that is 1.039 plus 4.2 multiplied by 10 to the power minus 3, and this would be equal to 1.039 plus 4.2. So it would be 5.239, that is 5.24 into 10 to the power minus 3 moles. Okay. Now we have got the final concentration of U238, the initial concentration of U238, the final concentration of U238. Now what is required? You want to find out the age, that is time, is equal to 2.303 by lambda log of initial concentration of U238 upon the final one. Right? I'll put it n over there and n. I'll write it properly. Huh? I'm sorry. So this would be n naught U238 upon n U238. Okay. So your lambda, now half-life is in the question, half-life given. Let's check out for the question. Yeah, the half-life of U238 is 4.5 into 10 to the power 9 years. So can we find out the lambda? 0.693 divided by 4.5 into 10 to the power 9. So what will be your lambda? Lambda would be 0.693 divided by 4.5, that is divided by 10 to the power 9. So it would be 1.54 into 10 to the power minus 10 per year. Right? Just put the values and get your age of the rock, that is a uraninite mineral. So it would be 2.303 divided by 1.54 into 10 to the power minus 10 log of, what was the initial concentration? It was 5.24 into 10 to the power minus 3 divided by, what is this? This divided by, what was the final concentration? 4.2 into 10 to the power minus 3. So it would be 4.2 into 10 to the power minus 3. So your time, that is age, will be equal to, so it would be 2.303 So here it comes out to be 1.49 into 10 to the power 10. So it would be 2.303 So here it comes out to be 1.49 into 10 to the power 10 log of 5.24 into 10 to the power minus 3 minus log of 4.2 into 10 to the power minus 3. So just solve this and you can get your answer. Right? So the answer, so it would be log of 5.24 into 10 to the power minus 3 is 7.193 into 10 to the power minus 4. That's minus 6.232 into 10 to the power minus 4. Or 7.193 minus 6.232. So we will get here log of 5 points, that is 1.49 into 10 to the power 10. Log of 5.24 is 7.193 into 10 to the power minus 4. and log of 4.2 log of 4.2 into 10 to the power minus 3 is 6.23 into 10 to the power minus 4. Right? So your time will be equal to 1.49 into 10 to the power 10 into, what you can do is 7.193 minus 6.232. This would be 0.961 into 10 to the power minus 4. Now this multiplied by 1.49, the time will be equal to 1.43 into 10 to the power how much? It would be 6 years. Right? Just solve this and you will get your answer.